Hi guys! I am Hazel Joyce Viseño, and our group will discuss about the trigonometric functions. But before that, let us define what is trigonometry. Trigonometry comes from the Greek words trigonon and metron, meaning measurement of triangles. There are 6 functions that are the core of trigonometry. And there are 3 primary ones that we really need to understand completely. The first one is sine. Second, cosine. The third is tangent. And there are another 3 that are not used as often and can be derived from 3 primary functions. These are secant, cosecant, and the last one is cotangent. And all 6 functions have 3 letters abbreviations. SIN for sine, COS for cosine, TAN for tangent, SEC for secant, CSC for cosecant, and COT for cotangent. And for the next presenter, let's have Miss Loris Manungay.
Today, I will going to discuss the definition of the 6 trigonometric functions. Consider the triangle above. There are 6 functions. Each function is the ratio of 2 sides of the triangle. The only difference between the 6 functions is which pair of sides we use. In the following table, A is the length of the side adjacent to the angle. O is the length of the side opposite to the angle. And H is the length of the hypotenuse. When we are going to find x using the 3 primary functions, the formula for sine x is equal to opposite over hypotenuse. Cosine x is equal to adjacent over hypotenuse, and tangent x is equal to opposite over adjacent. We're going to find for x using the other 3 functions, the formula for cosecant x is equal to hypotenuse over opposite. The reciprocal of cosecant x is equal to 1 over sine x. For the secant x is equal to hypotenuse over adjacent, and the reciprocal is secant x is equal to 1 over cosine x. For the cotangent x is equal to adjacent over opposite, and the reciprocal is cotangent x is equal to 1 over tan x.
Good day everyone, I'm Irrational and I will give an example involving 6 trigonometric functions. Let's have first a right triangle. Consider that hypotenuse is 2 and the opposite is y and the adjacent is x. So now I will define the angle A in 6 trigonometric functions. First is the sine A. Since we have the formula opposite over hypotenuse, therefore sine A is equal to y over 2. Next one is cosine A, which the formula is adjacent over hypotenuse. That's why cosine A is equal to x over 2. Next is the tangent A, which we have the formula opposite over adjacent. Therefore, our tangent A is equal to y over x. The next one is cotangent A. Since cotangent is the opposite of tangent and have the formula adjacent over opposite, that's why our cotangent A is equal to x over y. Next one is the secant A. Since secant is the opposite of cosines, therefore, our secant A is equal to 2 over x. And the last one is cosecant A. Cosecant is the opposite of sine. That's why our cosecant A is equal to 2 over y. Okay, let's move on to the next presenter, who is Oliver Murtos.
Hello everyone! Today, I am going to discuss the examples of trigonometric function using the formula SOHCAHTOA. For problem number 1, in the right triangle, if the given angle, angle A, is equal to 39 degrees and the hypotenuse is 30 meters. Find the opposite of the angle A. So, now, we are going to find the opposite of angle A, and we are going to use SO because the angle is given and also the hypotenuse. So, sine is equal to opposite over hypotenuse. So, sine 39 degrees is equal to opposite over 30 meters. Now, we are going to find the value first of sine 39 degrees. And the value of sine 39 degrees is equal to 0.63. So let us proceed to the operation. 0.63 is equal to opposite over 30 meters. So 0.63 is multiplied by 30 meters. Now, we are going to multiply 0.63 by 30. So, 0.63 times 30 is equal to 18.9. So, the value of x, or the opposite, is equal to 18.9. For example number 2, in the right triangle, if the given angle O is equal to 50 degrees and the hypotenuse is equal to 20 meters, find the adjacent of the angle O. So now, we are going to find the adjacent of angle O. And we are going to use Ka because the angle is given and also the hypotenuse. So, cosine 50 degrees is equal to adjacent over 20 meters. So now, same process. We are going to find the value first of cosine 50 degrees. So the value of cosine 50 degrees is equal to 0.64. So let us proceed to the operation. 0.64 is equal to adjacent over 20 meters. And now, we are going to multiply 0.64 by 20 meters. 0.64 times 20 is equal to 12.8. So, the value of x, or the adjacent of an angle, is equal to 12.8. For example number 3, in the right triangle, if the given angle, angle M, is equal to 14 degrees and the adjacent is 18. So find the opposite of the angle M. Now, we are going to find the opposite of the angle M, and we are going to use TOA because the angle is given and the adjacent. So, tangent 14 degrees is equal to opposite over 18. Now, same as the example, we are going to find the value first of tangent 14 degrees. And the value of tangent 14 degrees is equal to 0.25. So, let us proceed to the operation. 0.25 is equal to adjacent over 18. So, we are going to multiply 0.25 by 18. And 0.25 times 18 is equal to 4.5. So, the value of x, or the opposite, is equal to 4.5.
Okay, once again, I am Oliver Mortos.
I am Hazel Joyce Diseño.
I am Partial Relok.
And I am Luis Manungay.
Thank you for watching our video tutorial about trigonometric functions.